If you work with cylindrical parts, like shafts or pipes, you have to hold them securely to find center lines or measure runout. A V-block is mandatory for this. For decades, machinists have relied on standard clamped V-blocks. You set the workpiece in the groove, bridge the top with a strap, and turn the screw. The physical lock is fail-proof, but there's an alternative that drops the clamp entirely. Magnetic V-blocks use an internal system to hold the part from the bottom. You place the cylinder in the open V-groove, flip the switch, and the metal is secured. The physical strap on a standard block gets in the way. It obstructs your tooling access. In a repetitive workflow, measuring multiple parts in a row, removing and replacing that clamp over and over introduces a lot of friction. So we have to weigh the options. Is stripping away that top clamp worth the higher upfront cost and the strict operational limits of a magnetic block? Selecting a V-block comes down to matching the tools holding the mechanics to the specific friction points in your daily routine. To understand those limits, you have to look at how the tool actually works.